The first thing I want to be clear about is that there are two terms here, and that's why it's called binomial. And it's crucial that you understand that the first term is -1 and the second term is plus 2x. In other words, the signs are just as much part of the term as everything else. And my advice is to get into the habit of circling them. You're setting yourself up to never overlook this fact. Might not seem very significant, but if you establish certain steps that you follow every time, then under the pressure of an exam, you're less likely to go wrong. There are three principal steps to follow. And the first that we're going to do is to write down the combinations associated with each term in the expansion. And it's easy as long as you remember to start with the power of the expansion. And we'll just build them up like this. Now, to find the actual value of these combinations, you can simply use the NCR button on your calculator. So I'll press 3, Shift to get the NCR, 0. Find the value of that is 1. 3 NCR 1, the value of that is 3. 3 NCR 2, the value of that is also 3. And 3 NCR 3, the value of that is 1. Or if you like, we can construct Pascal's triangle. And you may know how we do this. 1 add 2 is 3, and 1 add 2 is 3. And each term is built up from the numbers above it, summing the numbers above it. And so on. But because the expansion is to the power 3, it's the third row that we require. But remembering that we start from 0, 0, 1, 2, 3. So it's this row that we want, and 1, 3, 3, 1. No coincidence that there are exactly the right number of values for the number of terms that we have. In other words, if you picked the wrong row, you'd soon find out because you'd have either one too many or one too few values. Now, take either term. It doesn't matter, although in the context of the questions, one may be more convenient than the other. But we'll take plus 2x. Put it in brackets, and then start by raising it to the power of the expansion, and then write it again, but one less, and so on. Until you get to 0. And then take the other term, put that in a bracket, but this time start from 0 and increase it by 1 each time. And then include each of your values of the combinations, and then we can just sum these together. So this is our expansion in unsimplified terms. Now, I wouldn't try to simplify this in one go. I'd introduce an intermediate step, and I'll just evaluate each of these terms one at a time. The most common error I see here is students will write this down as 2x cubed, but of course it isn't, because we are cubing the 2 and the x. And minus 1 to the 0 is 1. And having included this intermediate step, now I'll simplify the terms fully. And we're done. Here's another example, just to reinforce the procedure. Again, there are two terms and I'm going to circle them, so I can't overlook the sign. I'm now going to turn my attention to writing down the combinations required for each term. And again, as long as I remember, it's dictated by the power of the expansion. And I can use either the NCR button or Pascal's triangle. Again, this tells me I need the fifth row in Pascal's triangle, bearing in mind we start from 0. 0, 1, 2, 3, 4, 5, so here we are. And again, there is a fail-safe, because if you'd have picked the wrong row, I would end up with one too few or one too many values. Now I'll take either term, put it in brackets, and begin with the power of the expansion, and then write it down again, decreasing by 1 each time the power. I'll take the other term, put it in a bracket, but this time start from 0 and increase the power by 1 each time. And then I'll include the value of these combinations to each term. Before summing these together. So just like before, I need to simplify these, but I won't do too much at once. Avoiding that common pitfall, I've realized that I need to take minus 2 to the power of 5 as well as x to the power of 5. And having completed this intermediate step, I'll now simplify fully each term. And we're done.